Hello guys, last lesson of the week. Again, this is only a 4-day week. Tomorrow there'll be a short quiz over this information. Um, so everything that we've talked about. And there was no quiz last week, so there might be a few questions from last week as well. Don't stress out about the quiz. Remember, you get as many tries as you need, get as good a grade as you can. For now, we are covering graphing linear equations. And like what I've said on other lessons, a lot of this is just throwback to Algebra 1, stuff you already know how to do. Hopefully, this is not a real stressful new learning experience for you. Just an easy review, or if it's not easy, it's something you can become accustomed to fairly easily. So we are going to be graphing in standard form, which was a topic all by itself last week. So there's only a couple of these problems. I'm calling that just review from last week. Then we're going to graph in slope-intercept form, or the y equals mx plus b. That's been the focus of the other two lessons that we've done. So we're going to be applying that to graphing. And then we're going to look at equations that are in no particular form. They've got an x and a y in them, and you have to get the graph on paper. So those three things. There's no extra notes here, as you can see. We're just going to get right to the examples. Okay, so the first two problems are in standard form. So this is a throwback to what we did last week. And the method to graph these was called the intercepts method. I'll do number 2. Obviously, you're going to do number 1. So what you do is you take the x term, set it equal to the constant on the other side of the equal sign. And then you take the y term and set it equal to the constant on the other side of the equal sign and solve both of those. So set 3x equal to 3. When you solve that, you're just dividing by 3. You get x equals 1 and put a dot there. For the next one, you have negative y. Be sure that you make that negative go with the y when you set up your equation. And then to solve it, you would have to divide both sides by negative 1 in order to cancel that out. 3 divided by negative 1 is negative 3. Y equals negative 3 is right there. So you put 1 dot on the x-axis, 1 dot on the y-axis, and then just connect the dots, and you're done. So that was, excuse me, that was called the intercepts method, and it works when an equation is in standard form. So one of those for you to try. Then we get into 3, 4, 5, 6, 7, 8. These are all going to be in our y equals mx plus b form. And this is something you should have learned how to do, though I've had students in the past where this is a struggle because they didn't learn it so well in Algebra 1, or it's been 2 years and kind of forgot. So I'll just go over this like it's brand new. The first thing you want to do is plot the y-intercept. Remember that the plus b in y equals mx plus b, and that looks like a 6. Typical for me, I know. Oops, I deleted too much. Wow, and that m doesn't even look like an m. All right, I'm just doing awful right now. mx, here we go, plus b. So the b is the y-intercept. That's like your starting point. You always start with that. Plot the y-intercept, positive 4. That's right there. Now don't put it here. That would be the x-intercept, and the x-intercept has nothing to do with anything when you're doing this method. It's important up here. It's not important down here. The only thing that matters is the y-intercept. That is your starting point. Then you use the slope as your rise over run, and that tells you where to go from this starting point. So you put your pencil on this starting point, or pen or whatever. You go up 1 over 4 and put a second dot. Then you just connect the dots and you are done. That's it. Some people will go up 1 over 4, then go up 1 over 4 again and get a couple of dots to connect. And that's totally okay. All right, let's see that again. So negative 3 is your starting point. That's on the y-axis. Always the y-axis. It never fails. There's always someone who does it on the x-axis and ends up with a wrong answer. Oh, speaking of wrong answer, I should have been checking these. So let's check 2 and 4. So try to get number 2, the graph, number 4, the graph in your short-term memory. Let's scroll down and check 2 and 4. And yeah, those look about the same as mine? Not quite. I did a mistake, looks like on number 4. Yeah, apparently I can't count. What a maroon. This is up 1 over 4. I want up 1 over 3. Well, that's easy to fix. Just erase it and start over. A dot on 4, up 1 over 4. You can also go down 1 backwards 4, because technically negative 1 over negative 4 is the same thing as positive 1 over positive 4. So anyway, let me get rid of those extra dots. Connect these. And there you go. So, yep, made a mistake. Hopefully you don't hate me for it. If you hate me, it's hopefully for something more meaningful than that little mistake. There. Make that arrowhead a little better. There we go. Okay. So we're good. Let's go on to number 6. Negative 3, as we said, is the starting point, so I put a dot on negative 3. Now the slope is negative 3 over 2. Now there's 2 ways to look at this. Generally, you apply the negative to the top number. It's just kind of the way it's done. Negative 3 over 2 is down 3 and over 2, and it gives you a dot right there. And when you connect the dots, you get a line that looks kind of like this. Now, you could apply the negative to the bottom number, and that would be up 3, but backwards 2. And that would take you to a different dot, but it's the same line. So that would work also. What you cannot do is apply a negative to the top and the bottom, because negative 3 over negative 2 actually cancels and gives you positive 2/3, which is not the correct slope. So when you have a negative slope, just keep in mind, it's going to be a line that goes downhill. Generally, you go down and over to the right, and if you're just looking for one rule to follow, that's the rule, down and over to the right. But you can go up and over to the left and accomplish the same thing if you want to. Let's do number 8. Okay, now number 8, there is no y-intercept. So what's the starting point? Well, there's a number for not having a number, and that number is 0. Now we need a slope. Well, there's no slope there either. Well, y equals x is the same thing as y equals 1 times x. And if you're looking for a fraction, rise over run, 1 is 1 over 1. So from this dot, we can go up 1 over 1. In fact, you can go up 1 over 1 again and again and again, and then you get this slanted line right here. So hopefully that's good. You follow that. I've done one example with a positive slope. I've done one example with a negative slope, and another example with a positive slope, and that's kind of how your problems are right here. Don't forget, if your slope is a whole number, that you would put that over 1 in order to work out the problem. Okay, now we're getting into equations that don't fit any particular form. Remember, standard form, x and y are on the same side, and there's a constant on the other side. Slope-intercept, y equals mx plus b. That's where y is isolated. We have a method to graph either of those. Look at number 10. This equation is not in either one of those forms. It's just different. So generally what you do is convert it into one of those 2 forms. Which one? That's up to you. It's whichever one you prefer. I think for number 10, just my own judgment, I would like to change this to standard form, because all I have to do is bring the 6 over to this side, and I've got my x and y together. So that's what I'm going to do. I'm going to rewrite the problem over here. I'm going to show steps that I probably would normally do in my head. You're fine to show your work, or if this is something you do in your head, fine. Add 6, add 6. 6 equals 2y plus 4x. And then just kind of rewrite it. 4x plus 2y equals 6. That way it's in that form. Now remember the method to graph this. Take the x term, set it equal to the constant, and then take the y term, set it equal to the constant, and solve both of them. This one we have to divide both sides by 4. 6 divided by 4, it doesn't really divide out, but it does reduce to 3/2, which is the same thing as 1.5 or 1.5. So I'm going to put a dot on the x-axis at about 1.5. 2y equals 6, divide both sides by 2, you get y equals 3. I'm going to put a dot at 3 on the y-axis. Now all I have to do is connect the dots. Oops. And that should be that. Okay, could I have put this into mx plus b form? Yes, I could have, and I would get the exact same line. I'm not going to because we don't need the lecture to drag on and on and on. I'm sure there'll be others that work that way. Oh, number 12. Number 12 is in standard form. So let's look at this. Okay, so take the x term, 5x, set it equal to the constant, and take the y term and set it equal to the constant. And then solve them both. You get x equals 0. And then solve this one, you get y equals 0. Okay, this presents a bit of an issue because my x-intercept and my y-intercept is exactly the same. Well, to make a line, I need 2 points. I need two separate, like one x and two y, so I know what angle to draw the line. When the x and the y are the same angle, I don't know if I need to draw a line like this, or like this, or like that. I mean, there's infinitely many different lines that could go through there. So it turns out standard form set equal to 0 is pretty much worthless. So what I have to do in this one is I do have to put this in mx plus b form. So I'm going to go ahead and copy the problem down. In fact, I'm going to rewrite it like this: 5x plus 3y equals 0. You know you can do that, write an equation forward or backwards, it's fine. Subtract 5x from both sides. I get 3y equals negative 5x. Divide both sides by 3. Now, can you divide 3 into 5? No, just leave it a fraction, negative 5/3 x. And there it is. Now it's in mx plus b form. Now, what's the b? There is no plus b here. Their number for not having a number is 0. So the y-intercept is going to be 0. But now I have a slope that I can use to go from this point. I need to go negative 5 over 3. So down 1, 2, 3, 4, 5 over 1, 2, 3. And now I know what angle to draw the line. So even though this one was given in standard form, it was pretty much useless to graph. The regular method for graphing didn't work, so I had to do the slope-intercept method. And I just realized I have not been checking myself, have I? What a loser. All right, so 6 and 8. Let's get a short-term memory look at those. 6 and 8. I think those are pretty good. And then 10 and 12 look like this. I just did 12. 10, let me scroll back up and see how those look. Yeah, they look pretty much just like what I did. So we're okay. Number 14. Number 14 is kind of in standard form. If we really want this to be in standard form, remember that that's supposed to be a positive number. So what you can do is divide everything by negative 1. And this will turn into positive 3x plus 2y equals positive 4. Now we can set the x term equal to 4 and the y term equal to 4. So again, we're using the intercepts method. Solve each one. We're going to divide by 3. 4/3 is the same thing as 1 and 1/3, not 1.1/3. Geez, where did I learn math? 1 and 1/3. This one, divide by 2. 4 divided by 2 is 2. So my x is going to go right about there, 1 and 1/3. Y is at positive 2. Connect the dots as good as I can. And that's a fairly straight line. And now I'm actually going to check 14, unlike the other problems where I just blew through them. Come on, where's number? Oh, good grief. There it is. So yeah, we see it 1 and 1/3 and positive 2. Okay, let's go to, now, if you're saying, well, that isn't exactly 1 and 1/3, yeah, you're right. I just had to estimate where it goes. Okay, let's look at this one. This kind of is special. There is an x but no y, and I talked about this earlier this week. Do you remember what type of an equation has x but no y? Okay, if you said vertical, you are correct. X equals 3 is a dot right here. That means there's an x-intercept, but there is no y-intercept. So this line cannot be slanted because it would intersect the y-axis. If it's not slanted, it has to go up and down. So when there's an x with no y, it is vertical. What if you have a y with no x? Do you remember this one? It's horizontal. If there's a y with no x, y equals -1 is right here. There is no x-intercept, so you just draw a horizontal line through that dot. And that's all there is to that one. All right, let me go ahead and check 16 and 18. See if I have a vertical and a horizontal line. 16 and 18. And no surprise, look at your assignment. You have a horizontal and a vertical line also. So keep that in mind as you do your work. So there you have it. Graphing. The intercepts method, which we already covered. Y equals mx plus b, which is technically new for us, but you should have learned last, well, at least in Algebra 1 when you took it. And then graphing in no particular form, basically you turn this problem into one of those two forms. And don't forget vertical and horizontal. Vertical is when you have x equals some number. Horizontal is when you have y equals some number. All right, I'm going to stop there. Contact me through the usual methods. If you have any questions, I'll do my best to help you. Otherwise, I will talk to you.